Hi, everyone, and welcome to Backer Breaks It Down. In this episode, we explore dilations. This screen shows an example of a dilation, right? So this right here is a dilation. What do you notice? What do you wonder? So you recently investigated dilations when we were in class earlier. Basically, in a dilation, the image and the pre-image are similar because they have the same shape but different sizes, okay? In fact, this little GIF over here is showing you a dilation, okay? In blue, you have the pre-image, okay? And our image in red is changing, right? It's either getting larger or smaller than the pre-image, okay? But they maintain the same shape, they're just different sizes. Now, corresponding side lengths are proportional, which means they're related by something called a similarity ratio. It's the ratio of any side length in the first figure to the corresponding side length in the second figure. And corresponding angles, they're going to be congruent. So to get into some specifics about dilations, which is also known as a similarity transformations, the lines connecting every point P with its image P prime all intersect at a point C called the center of dilation. So here you have P, the point on the pre-image, P prime is the point on the image, and notice that the same line is connecting those two to the center of dilation, C. Now, the ratio of CP prime to CP is going to be the same for every point P. And that ratio is the scale factor, the ratio of any linear measurement of the image to a corresponding measurement of the pre-image. Okay, so this means that I can use those distances. Each point is from the center of dilation, but I can also use the lengths of corresponding sides or segments. Okay, so that does mean that I can use if this is 6 and if this is 3, I can use those because those are linear measurements in order to find scale factor as well. So I can use the distance each of those points are from the center of dilation to find scale factor, or I can use segment lengths. Okay, so here is an example of what I'm saying. It asks us to find the scale factor. Okay, so you'll notice that the figure in green is the image, and I know it's the image because of those little tick marks, these little primes. See that? How they have those little tick marks? Okay, those indicate the image of the dilation, and the image is the result. Okay, so in green we have the image, and in pink we have the pre-image. And so when it comes to finding scale factor is always found, we call it K for scale factor, image over pre-image. So one way of doing that is to use side lengths, and that's what they're showing in the left column here. They're using so you can use this has a side length of 4 and this is a side length of 2. And so I can say 4 over 2, it's kind of weird what they're showing here. So K is equal to 4 over 2, which is 2. So we always want to simplify those ratios. Another way of doing this is to use the distance each point is from the center of dilation. So that's these right here. And 8 is the distance associated with P prime, and 4 is the distance associated with P. And so that's what they're calculating here. They're getting the same scale factor of 2. So you can use any linear measurements, so side lengths or distances from the center. So in problem number 1, it says find the scale factor of the dilation and then set up and solve a proportion to find the value of the variable. Okay, so I need to take a linear measurement from the image and put that over the corresponding linear measurement of the pre-image. And so when I look at my diagram, I want to make sure that I'm picking well, a pair of corresponding parts where I know each of these things. So I like these two numbers here. They are corresponding parts. The 42 is associated with the image. So I'm going to say K is equal to 42 over 24, and then I'm going to simplify this. Both of these are divisible by 7, so when I simplify this, I'm sorry, both are divisible by 6. So when I simplify, I get 7 over 4, so that's my scale factor. So for my proportion, I have an option. I could totally use that original ratio of 42 over 24, or I can use my scale factor. I think the scale factor is easier to work with. So I have 7 over 4. Right? I'm creating a proportion. Now I want to find B. B comes from the image, and remember the image is on top, and the corresponding linear measurement would be 10. So here's my proportion, okay? And then I'm simply going to solve this proportion using the cross product property. So in the cross product property, I find my cross products. So I go 7 times 10, and that's 70. And I say that this is equal to 4 times B. Okay, that's the cross product property. And then, of course, using our amazing algebra skills that we entered this class with, we divide both sides by 4, and we get that B is equal to 17.5. Now I can classify my dilations as enlargements or reductions. It all comes down to that scale factor. So when the scale factor is greater than 1, that's an enlargement, and when it's in between 0 and 1, that's a reduction. Granted, it's also kind of obvious when you can see the image and the pre-image, whether it's an enlargement or a reduction. So the scale factor is just confirmation of that. So in problem 2, it says identify the dilation as an enlargement or a reduction and find its scale factor. So I just got done saying it's kind of obvious. So if blue is your pre-image and red is your image, clearly this one got smaller, so this would be a reduction, right? So it's kind of obvious. My scale factor will confirm that because my scale factor is equal to image over pre-image. So my image value is 2 and my pre-image value is 3. Okay. And B, blue is the original, red is the image. Clearly it got bigger, so this is an enlargement, right? And then my scale factor is image over pre-image. So the image is 2, the pre-image is 1, so I can say 2 over 1. I can also just say 2. And so those are the basics of dilations. So in dilations, we're talking like the pre-image and image are similar to each other, which means the corresponding angles are congruent and the corresponding sides are proportional. And the scale factor can be found by taking any corresponding pair of linear measurements from the image and pre-image and finding their ratio. And that's how Backer breaks it down.